Hey everybody, Scott from Octava Engineering here again with our third kind of how-to video for SICK Hyperface. If you haven't watched the first two videos, please go back and watch those first before we dive into this one, because I'm just going to kind of gloss over what we've already covered. So for this third SICK Hyperface video, we're going to talk about what to do in the event that you get a motor with a Hyperface encoder that does not have memory programmed onto it. And to give you an example, I have my drop-down selected here, ending in auto-identify. And when I go to click Start Collection, we get this pop-up here. Motor information cannot be identified, commutation value may not be calculated, all other features are available. So if you see this pop up on a type of motor that you know should have memory, specifically like Allen Bradley or Rex Roth, just as examples, then that means that there might be a problem with the memory that's programmed onto the encoder. However, as I mentioned before, there are certain manufacturers out there that use SICK Hyperface encoders, but do not use any memory or any commutation offset that's available on those encoders. So in that case, and this is correct, motor information cannot be identified, you could still complete an evaluation test or an analytics test here in the analytics module. I'm not going to go through and do that here. But after you run the analytics tests, you're going to want to go into encoder and memory, click on the SICK logo, and see if there's any memory actually programmed onto the encoder. So in this case, we're communicating with the encoder, no problem. You can see it's returning, the encoder type, the space versus what's used, and you can see there's no memory size or number of data fields used. Encoder firmware, encoder serial number. So we're communicating with the encoder without a problem. However, there is no motor-specific memory loaded into the encoder. It's just a blank encoder. Now again, in certain cases, depending on the motor manufacturer, that could actually be a problem. Again, most commonly Allen Bradley and Rex Roth. But there's other motor manufacturers that will not utilize this space. Or sometimes they will utilize this space, but there won't be a commutation offset setting into it. So in that case, what do we do as far as finding and performing the correct lock-in to do the alignment? So for that, let's go over to our motor lock-in module. And again, there's that motor information cannot be identified. And then when you click on the alignment toggle, there's no lock-in sequence given, which means we have to find or create our own. Obviously, it's best practice to verify the incoming alignment on every motor whenever you possibly can anyway. But in this case, we have to find it so that when the motor is rebuilt and we reset the encoder, we're setting the encoder back into the correct position. So I have this motor hooked up to my align mate. I have the align mate turned on. I'm going to manually rotate the shaft until I'm close to mechanical angle 0 here. And then I'm just going to use these toggles to find which lock-in gets me closest to mechanical and electrical angle 0. And I'm going to start at U positive, V negative, which brings me to mechanical angle 49 degrees. If I go W negative, that brings me farther away from 0, so I'm going to go W positive, which brings me closer. And then from there, I'm just going to rotate my toggles until I get to the closest 0 position that I can. So I'm going to go U off, U negative, V off, V positive, W off. Now you can see I'm getting very close. W negative actually brings me past the 0 point to 357. So in this case, what I would like to find is a true 0 alignment. And if that's the case, then I just have to record the lock-in and remember what the lock-in position is for 0 degrees. However, this one is going to have what we refer to as an offset. So the closest I can get is either about 350 or about 15 electrical degrees there, crossing over the mechanical angle 0. So I'm going to record the lock-in value of U negative, V positive, and I'm also going to record the electrical angle offset of 15 degrees. So once I have that information stored, I'm going to hit Stop Collection. I'm going to go to my More button here and click on Preferences. I'm going to go to Add Motors. I'm going to go to SICK. You can see my action here is defaulted at Add. I'm going to enter a new entry and basically add this motor to my software. You would use the motor manufacturer, the model number. For now, I'll just write in test. I will select the lock-in that I found of V positive, U negative. And then in this commutation offset field here, I'm going to put in that 15 electrical degree value that I found. So once I have that information entered, I will click Update. You can see the status here says motor added, and I get a pop-up saying, please restart the software to apply the changes. So I will restart the software. Remove my CN1 so I don't blow any fuses while it does the self-diagnostic check. All right, now that the software is back open, I will plug my CN1 back in. And now if I go into Analytics or Lock-in or any of the modules, select Serial, SICK, Hyperface, number of pole pairs of the motor. And now for the motor manufacturer tab, you can see that the motor that I added is now present. So with the motor that I added, now if I click the alignment toggle, you can see the lock-in sequence that I entered for V positive, U negative. And you can see that instead of the traditional electrical angle 0 giving my alignment point true, you can see that it's falling in under 15 electrical degrees there. So if I move over to our lock-in module, and I click the alignment toggle, it's telling me the lock-in sequence that I entered. I'll just move it out of alignment here so we can see. Now you can see that's coming up true. So when I go to reset this encoder onto the motor after the motor's been rebuilt, I'll have the lock-in sequence and I'll have my alignment point true at 15 electrical degrees. Now, in certain situations, it's almost impossible to manually set a SICK encoder, especially if it's an SKS or an SKM style where you have to screw the encoder shaft into the motor rotor. For those instances, we do have this position right feature. This position right feature is password protected. And that is there as a safety feature, because if you are working with an encoder that does have a commutation offset stored into it, you never, ever want to use this position right feature. You always want to use the commutation offset, the calculate and write that would normally be here in the lock-in toggle. So we leave that password protected on purpose. However, if you do need it, please reach out to us at support@octavaengineering.com, and we will share that with you and just kind of walk through and make sure that everything is done properly so you have a good alignment. So this value is also what the system will look for when you go to do any of your evaluation or final run tests in these modules here. But that is what to do and the steps to perform in the event that you're working with a motor with SICK Hiperface that does not have the commutation offset. So you can still test it. You can still test the signals and analytics. You may just have to add it to the system so you can properly perform the alignment after the motor is rebuilt. So that's it. Thank you very much for watching, and we'll see you in the next one.